Alright, so this video is going to start introducing the idea of fixtures, and I'm going to do the fixture description over a few videos. Now this is the bingo box that John has produced, so you can see it's got a tilting top face, and it's got some sides and back and bottom, etc. Now I'm using this because it'll give a good example as to one of the things fixtures can do. What fixtures do in JDC&C is they allow you to marry the graphics with the physical workpiece on the milling machine itself. And so in terms of the graphics, it tells you where is your starting point, and that can refer to the touch-off point when you put the raw material onto the machine physically. It also says this plane, if you can see that, like if I'm working on this plane here, that's a flat face, but this top is an inclined surface. But if I want to machine that, if I want to put a board flat on the milling machine and machine that out, then I need to consider that this is a flat plane, and that this flat plane here will marry to the flat plane of the XY plane of the milling machine when we start. So the way you can do that, let's just generate some G-code. So what I'll do is I'll place a coordinate system to represent the plane. Now, when you place a coordinate system, the first point tells it the origin of it. So I'm going to right click vertex and click vertex location. And you can see the second point tells it where the x-axis is. So if I zoom out, come over here, and I click on that vertex, then that gives the x direction, and the next point tells it where the y-axis and therefore the z-axis is. So if I come up to this corner and click on there, then those three coordinates are enough to define that coordinate system. And you can see that the x-axis is along that line and the y-axis is along the surface of this inclined plane. So this coordinate system really is defining the fact that this flat surface, this is the starting point. So when I touch off my raw material on the machine physically, if I say the raw material and touch off and say this is the 0, 0 point, then really this here is where the 0, 0 point is in my graphics. Now, in order to marry that coordinate system object with the fixture, we'll add a fixture here. Let's give this a title so that it makes more sense to us. So G54, and we'll say slanting top face of box. All right, and we'll grab the coordinate system object that we've just done. So right click and copy, and I'll paste it into this coordinate system object. Oh, sorry, I should have done paste it, copy into. So when I'm sorry, copy here, paste into. There you go. So now this coordinate system object there is a child of that fixture object. And then when we machine it, the G-code will be generated for that fixture. And then when we affix the material to the workbench and touch it off, we need to say this is our starting point for this surface. All right, so let's just say we'll machine the outside of this thing. So let's just grab the face and make a sketch from the face. Now that sketch runs around the outside, the top outside of that face. So let's create a contour operation on the outside of that. We've got 4 tabs, that's right. From 0 to -7, near enough, that's okay. And we'll grab that. Now, the thing is, at the moment, we really want this coordinate system tied as a child of that fixture. So I can just drag it down onto that contour. So now that G54 fixture is now a child of the contour, and you can see it in the name here. So the G-code for this contour will only be generated for the G54 fixture. It won't be generated for G55 or any of the other coordinate systems. And so if I generate the G-code for that now, I'll just ignore that the tool length warning, you can see that it's generated G-code around the face of that surface, so that it's going to start cutting from the face of the surface and then running down layer by layer. But it's following the tilt of that surface because our coordinate system object follows that tilt. So let's just continue on that thing. Let's go and have a look at the left face of it. Let's do the same thing here. Let's say we wanted to machine, put a hole or machine around the outside of this left-hand face. Well, again, we place a coordinate system. Now we'll go in and I'll click on the that corner vertex. I'll say that's my starting point. Now my x-axis is going to run across to here, so I'm going to say click on vertex, click here, and then the y/z axis, or y-axis, will end up being up to this point here. There you go. So those 3 points are enough to fix this coordinate system. So there's x, that's y, and z is coming straight out from that page. Let's define another fixture, which will be G55. But let's say this is for the left hand face of the box. Say now we'll grab that coordinate system object, copy, and I'll paste into. There you go. So now this G55 fixture is referenced to here. So this is the 0, 0 starting point, and that's the plane of machining. And if I, it's the same thing, let's just grab a face, generate a sketch around the outside of that face. We'll generate a contour operation from that. And for this contour, we really want that contour to only be machined for the G55. So we'll drag that one down there. So and now that we've got two fixture objects created, when we generate the G code, we're going to get this extra dialog pop up. It says, well, do you want to generate G code just for G55 or just G54, or do you want to do it for all fixtures? Now let's think, for example, let's say this box was a plastic box and we were machining some holes into it. You might just want to generate the G code just for the G55 coordinate system, and click OK, and it will generate whatever G code is just for that coordinate system. So you might affix this plastic box into your vise, so sticking up sideways so the left hand face is facing up towards the milling bit, and then run the G code just for that face of the operation. And then you might, the next time around, you might fix the box so that the top face is flat again in the vise, and you might want to generate the G code just for the top face of it, and there you go, that's the G code for that. Or of course you might have multiple boxes in your oil mill, all with different touched off coordinate systems, and you can generate the G code for all of them, and it'll do that just for that. So you get the idea that the idea is that the fixture is a coordinate system which gives you the starting point, 0, 0 coordinate, as well as the plane of where's the x and y axis, what plane is it on, where does it all start. And that describes it in terms of the graphics file, but it also describes it in terms of the G54 or G55 coordinate systems on the CNC milling machine itself. So when you put some raw material down on the machine and then you touch off, you're saying, righto, CNC machine, this is the location of the 0, 0 point for G54, for example, or G55. So a fixture in JDCNC is all about marrying the graphics to the raw material on the mill itself, and it's all about those associations. Now there's more flexibility and more things you can do with it, and I'll describe all those extra things in new other videos, but that just gives you an idea as a starting point. That's why we would use fixtures. Is if you had if you had a 3D model, for example, and you wanted to machine them in separate setups. So if you wanted to put the box sideways in the vise, clamp it up, and then machine the left-hand side face, and then you would move the box, rotate it around in the vise, clamp it off again, and run another program. Well, you can generate the G code or the G code programs all from your 3D model for each of those different machining operations. Anyway, look, that's just the part one of the fixtures video series, so I'll stop there on that one, but you get the idea.